Hey everybody, Garrett here with AppMap, here to talk a little bit about runtime analysis, kind of what it is, how it works, how it differs from some of the other analysis tools and code analysis tools you may have looked at or worked with in the past, and specifically what AppMap's unique approach is to this and why it's an incredible solution. So let's go ahead and get started, shall we? First things first, what is runtime analysis? Well, pretty self-explanatory. You're analyzing your code at runtime. You're specifically, though, looking for flaws in your application or weaknesses or common weaknesses in your application. Uh, Traditionally, that happens with a static code analysis where it's going to look at patterns and various different things, but it actually creates a model of your code rather than actually running it and tries to predict what the data will be like as that code is executed. Um, or it can be done in the production environment through something like an application performance monitoring tool, which is incredibly robust and can give us all sorts of insight into what is actually happening when the application is running. But they are incredibly cost heavy, as well as difficult to work your way back into the code. So AppMap's unique approach to this is to do it at runtime in the dev environment. So during the development lifecycle, you have your different stages that you can deploy to, you have your different testing phases and your different places that you can deploy to. AppMap decided we were going to shift it back into the dev section of that. So what we actually do and the way this actually works and the way that runtime analysis occurs in the AppMap world is we have this wonderful mapping tool that goes through and watches your code as it's running in real time, and it puts fence posts and flags along the way on when events specifically occur inside of the operation of your code, what the data is at the time of that operation, where it was called, things like that. And we build these beautiful diagrams for you. Because we have the ability to do that, and because we have the ability to build these diagrams for you, we also have the ability to use some of those flags during that instrumentation phase of your development for our advantage or toward our advantage. So we went ahead and we created our analysis tool. Now, that analysis tool looks like this. It's incredibly simple as far as what you can see and what a user can see, and it comes with some default rules. These rules are part of a scanner. That scanner runs these rules and cross-references these rules to what is actually happening in your code to find flaws. Now, what do I mean by flaws? Flaws are different than bugs. Bugs happen as a result of something going wrong, something being undefined, passing the wrong data, passing the wrong value, whatever the case may be. Flaws are actually fundamental structural problems in our code. They're problems with the design or the way we are actually handling our code or our code's behavior when we are handling data. So these rules are extrapolated or came out of this website. This website is called Common Weakness Enumeration. For those who are unfamiliar, it's CWE. It is an open source space where really it's run by a bunch of high level organizations and companies that security and maintainability and performance are paramount. So they create these rules of common issues that can occur in applications. If we look at the OWASP top 10, these are ones that are actually mappable. And if we click on one of them, we can understand like how it occurs, where it occurs, why it occurs, those types of things. Well, that's what all these rules are. They're actually mapped directly to something on that CWE website where it is actually looking for these common issues in your code by utilizing some of those fence posts. Unlike a static code analysis, where it just kind of guesses and creates a model of what your code would do, we actually run it. So let's talk a little bit about how to set it up. Like I said, by default, it comes with a bunch of 12 different rules. There are other rules out on our website. You can see it in our documentation that you can add by simply adding an appmap-scanner.yml. By adding these rules, it will override or pick up where the scanner left off in the default rule set and run additional ones. The best part about this is AppMap has actually made it even more extensible. So they've actually given us a peek behind the curtain where we can see how rules are constructed, how essentially to write one, and we can actually write our own rules. So if we had an application or a library that we didn't want to be called too many times, we could actually look for instances of that by creating our own rules. We'll create a video to show you how to do that later on. This is actually the kickoff video for a series where we'll go through each one of these rules and kind of discuss how to use AppMap to find them, where to find them, whether they're worth fixing, and how to fix them in some cases. A link for the next video in the series should be up in your upper right corner. But just to recap real quick, runtime analysis by AppMap is an incredibly powerful tool that can help you find flaws in your application before you have to spend the money in APM and before it actually goes to production. So thanks everybody, and we'll see you next time.